Hello students. So in the last class we had discussed the general relation of uh, for acceleration. Okay, like if a particle is moving on a general curve, what would be its acceleration in general possible? Okay, so there we had discussed that this is what its centripetal acceleration, guys. This will be what it's, you can say, the acceleration that will be what in the radial direction it would be having. Okay, then we had this is what, guys, we have called tangential acceleration or the Euler acceleration. And the last one, guys, we had discussed, that is what, that is your v rotation. Okay, that is Coriolis acceleration that we had discussed. And we had discussed at that moment only the rotating frame. Okay, so rotating frame we had discussed at that moment. And then I had told you that we will discuss now at the end the fictitious forces. Okay, so guys, uh, again this lecture would be again little bit what, you can say, a tricky and a bit complex. So pay attention, then only you will understand, because we are at the verge of what, just completing this chapter. Okay, so just let me write down first what we have written here. That, guys, if you see, the a acceleration of the particle in general will be what, guys? It is omega cross r plus r dot r cap plus, guys, alpha cross r plus 2 omega cross v rot or v rotational, guys. Okay, so this we have discussed, that what is v rotational and everything, guys, we have discussed already. So guys, now if you see this that we are discussing is actually, guys, what, in the ground frame. Okay, in the ground frame, this would be the acceleration of the body if it is moving on a general curve, guys. Okay, but suppose if you are sitting in a rotating frame, guys. Okay, so let me show you a situation so that you can understand this. So suppose, guys, if I show you a top view. Okay, let's say there is a particle here, guys. Okay, and we are sitting here at this. Okay, we are sitting here at this axis. This is, let's say, x, and this is y, guys, and z is in the what, in the upward direction. And let's say guys, the body is moving, guys. Let's say this body is moving on some sort of this curve. Okay, some sort of this curve. Okay, we don't know like in general what is the path that it is following. But if you see, guys, let's say uh, if it is going like this on this path. Okay, if it is going like on this path like this. Okay, then what we are doing, we are also shifting our axis like this. Okay, we are shifting our axis like this, so that we are seeing this body always what, along the x-axis only. Okay, along the x-axis. Then, guys, we will call that our rotating frame is watching this body always what, just moving away, but not moving with some angle. Okay, so in that case, guys, if you see, okay, in that case, what is going to happen? If you see, suppose the rotating frame that you are having is having angular velocity, let's say, guys, what, omega. Okay, rotating frame that you are having, guys, let's say it is having angular velocity what, omega. And, guys, if it is seeing that the body is going away from it, okay, with a speed of what, let's say, v rot at some instant. Okay, we wrote at some instant. So this would be the picture that, guys, we are going to see. So at that moment, guys, the acceleration the particle will be having is what, this much. Okay, but, guys, see, sorry, uh, I did some mistake, guys. Here if you see, this is what, guys, for the ground frame. But, guys, if it is watching from here, it will be just seeing only, guys, what, that the body is going away, so it will be having acceleration, guys, what, in the outward direction, not in this direction. Okay, like there would be no radial sorry tangential change we are going to see, only, guys, radial change we are going to see. Okay, so, guys, if you are sitting in such frame like this rotating frame, if you are sitting, okay, if you are sitting in this rotating frame, which acceleration guys you are going to observe in that case? In this case you are going to observe the acceleration is equal to what? R dot r cap. Okay, this is the thing that you are going to observe. Okay. So guys, we know that in a in a non-inertial frame, non-inertial frame in a non-inertial frame guys, what is the Newton's second law guys? We write F real plus F pseudo is equal to what guys? Is equal to mass into acceleration observed from the non-inertial frame, which is guys here is a what? Your rotating frame. Okay, so what we guys call here that F pseudo, let me put it like vector form only guys. Okay, so F pseudo will be what guys? Simply ma, which is what guys? Observed from the non-inertial frame minus guys what? F real. Now guys, if you see the F real is simply is equal to what guys? Mass into acceleration in the ground frame, in the ground frame. So guys, if we put all these things, so we can get what would be the F pseudo in general. Okay, so guys, if you see the F pseudo, what we are going to have is equal to what guys? M into guys A observed from the non-inertial frame, that is rotating frame, is what guys? Is only r dot r cap, because guys only the body will appear to us what? That it is going outward. Okay, it is going what? Outward. So guys, this would be what? Our rotating frame acceleration that it is going to observe. Okay, suppose guys if it is moving in such a way, then okay, so we will have what? This as a what guys? Our acceleration. Okay, so guys if I put this here, what I'll get? This will be r dot minus r cap minus guys what? F real. F real is equal to what guys? Mass into A in the ground frame guys, and that is nothing but what guys? That is A ground frame is what? It is guys what? It is this only. Okay, it is this only, nothing else. Okay, so if I put that guys here, what I'll get? Omega cross r, okay, plus r dot r cap plus alpha cross r plus 2 omega guys, 1 minute, 2 omega cross v root. Okay guys, so this would be the case guys. So if I simplify, so guys what we are going to get? The F pseudo in this case would be what guys? If you see m r dot r cap is going to be get cancelled guys, so what we are going to get finally? Minus m omega cross r plus guys m alpha cross r. Okay, 1 minute guys, sign I have done some error, just let me correct this guys. Here it will be what? Minus only. Okay, so it will be minus, and then guys what? Finally minus m 2 omega cross v root. Okay guys, so finally guys we got the all the pseudo forces that would be acting on a body if it is moving on a general curve. All the possible pseudo forces guys we have written here, that is what? Minus m omega cross r minus m alpha cross r minus 2m omega cross v root guys. Okay, so these are the three pseudo forces guys with whom we have to deal with if you are sitting in a rotating frame and you are observing a particle which is moving on a some general curve. Okay, So guys, here if you see this force guys, okay, this force, its direction guys, if you see, it is going to be what, if you do the math guys, you will see that it is going to have what, if you just check with the cross product, okay. So guys, what we will get that it is coming in the outward direction of the radial direction, okay. So basically it will be what guys, in the radial outward direction. So guys, this force, this fictitious force is known as what guys, centrifugal force, okay. I'll simplify the formulas for you later, but guys, this I would advise that we have to remember this as a vector form only, because many times the students get confused and then the problem happens, okay. So guys, this will be what, your centrifugal force, and then this will be what guys, this will be our uh, Euler force, okay, Euler force, which is also a fictitious force guys. And then of course the last one guys is what, Coriolis force, okay, Coriolis force, that is the last fictitious force, okay guys. So there are these three forces that we might need to apply in a particular situation if we are sitting in a rotating frame and observing the particles guys, okay. So this is the concept that I wanted to discuss, okay. And sorry guys, okay, so now we can see some examples to understand and to apply these concepts in a different situations guys, okay. So I hope you understood this. Okay, let's start to understand this idea guys, okay. So the Euler force, centrifugal force and Coriolis force guys, we are going to see in a particular situation. So I'll take one example and I'll just show you that what would be happening in this situation. So guys, if you see, suppose there is a problem number one guys, okay. I'll show you an example so that you can understand what is actually happening here, okay. Guys, if you see, suppose uh, one disk is there guys, okay. This is a actually J advanced problem that have come, I think, in 2017 or 2018. From there only guys, I am taking this problem a little bit similar to that, just giving you some fundamentals that how should we approach, okay. So guys, if you see here, uh, this is a groove guys, okay. 1 minute, just let me put it little bit properly. I think now it is looks fine, okay guys. So here if you see this is a guys what, a thin groove that we are having, and this is its center guys. The radius of this disk guys, we can take as r, okay. The disk radius is guys what, r we can take, and there is a particle, or you can say guys a body, which has been just placed just touching to what, to the groove walls, okay guys. It is just touching the groove walls, and guys, at any general movement, the groove is rotating, sorry, the disk is rotating guys with what, omega velocity, and at the same very moment guys, it is having some alpha at that moment, okay. Some angular acceleration it is having guys in the same direction, and the omega is also guys, it is having in the same direction. And guys, it has been observed that, let's say, the particle is moving with velocity v in the with respect to what guys, groove, okay. With respect to groove, its velocity is what guys, it is what, v, that has been given to you, okay. The velocity with respect to groove guys, remember, okay. So it means we are sitting in the groove, then we will see the velocity is how much, v, okay. So this is given to you guys. Now they are asking, find out find out find out the normal force, normal force applied by the groove walls, groove walls, okay. That's it guys, okay, groove walls. This is the question that they are asking, okay. So guys, in this case, if you see the actual thing, what would be happening is guys, if we sit in this frame, okay, then I think we can picturize what would be happening guys. So if guys I sit in this frame, okay, if I sit in this frame and my let's say this is my x-axis guys and this is my y-axis, and I am sitting, and guys my eyes are what, just continuously what, watching this block. So guys I would be also rotating with what, this omega, okay, velocity, and I would be also having what, the same acceleration that the disk is having. Okay, so alpha would be what, my angular acceleration at that moment, and guys omega will be what, my angular velocity at that moment. And at that moment I would be watching the block going outward guys with a velocity of what, v. Okay, so that would be what guys, my v road. That will be why guys what, my v road, because with that velocity only I am seeing that the body is what guys, moving away from me. Okay, so that will be what guys, what my v road. I hope this is settled for you. So guys, if you have understood this, what we will do, first we will see that what would be the fictitious forces that we have to apply on the body. So guys, if you see, if I make the FBD of the body guys, what I will write, I will write that there would be, in the outward direction guys, I have to apply a centrifugal force. Okay, and the centrifugal force will be what guys, that is m omega cross r guys, which is what, if you see, this is what guys, this is simply omega square r. Okay, omega square r, m omega square r guys, outward direction, that would be the thing that you have to keep in mind guys, it is always radially outward, and its magnitude is what guys, m omega square r, where r is the distance from the rotating frame. Okay, so m omega square r, the centrifugal force that we are going to write guys, and this will be what guys, m r alpha we are going to write, and it will be always opposite to what guys, alpha. Okay, it will be always opposite to what guys, alpha. And for this guys, for this you have to do what, you have to see that what is the v rotational you are getting, and then you have to do this omega cross v rod, and then of course negative sign you have to multiply with that, means the opposite vector of omega cross v rod you have to write. So guys, I would advise that you remember these two directly, like this is what, in the outward direction m omega square r, radially outward guys, this will be what, opposite to the the tangential acceleration that the body is having, opposite to that guys you have to apply. And this one guys you have to remember as a vector form, that is what, 2m v, sorry, omega cross v rod. Okay, so guys this you have to keep in mind as a vector form only. This might you like guys remember in a general way also, that would work, but guys here you might get confused, so that's why I would advise you that you remember this what, as it is, it has been written here. Okay, so guys here if you see, the centrifugal force that we are going to write guys here is, actually it is what, m omega square r in the outward direction guys. Okay, and now guys if you see, because alpha is in this direction, it means tangential acceleration will be what guys, in this direction. So the Euler force will be what guys, acting in this direction. Okay, if you are sitting in the rotating frame, so this force you have to apply guys here. So we will apply this force guys here, and that is what, that is m r alpha. Okay guys, let's say this distance right now of the particle is what, from this center is what guys, r only. I have forgot that to write. Okay, so guys this is what, r from the center. Okay, and if you see guys, the omega cross v road, if we want to write guys, so omega direction will be what guys, because if you see the disk is moving in the anti-clockwise direction guys, disk is what, disk is moving in anti-clockwise direction. So guys the direction of the omega will be what, in the upward direction. Okay, it will be what, in the upward. Okay, and v road is what guys, in this direction. So guys omega cross v road if you do, okay, omega cross v road guys if you do, that will come in this direction. So minus of omega cross v road guys would be the direction of what, the Coriolis force. Okay guys, so the Coriolis force will be what guys, also in the same direction of as Euler, and the magnitude will be what guys, 2m omega into v. Okay, which is v root only guys in this case. Okay, so guys this will be what, our two forces. So guys, of course, because if you are sitting in the rotating frame, you are going to observe that the body is, as if you see, if you are sitting in this rotating frame, you are going to observe that this body is not moving in this direction. Okay, and because if it is not moving in this direction, according to you the net force in this direction should be what? Zero. So because guys these two forces are acting in this direction, there should be some force that should be acting in this direction which is balancing this force. Okay, so of course who will be balancing guys? This. So nothing else, the normal force should be what guys? Balancing this force which will be in this direction. So guys what we can say, that normal force is equal to what? It will be m r alpha plus 2m omega into b guys. Okay, so that would be the force. And of course there would be one force that is acting from the what? From the grooves floor. Okay, which will be balancing the mg. Okay, but that they haven't asked. They had asked guys what? The force from the wall. So that force will be what guys? This force, which is what? The sum of Euler force and the Coriolis force guys. I hope this is settled. Okay, so I have just taken guys one simple problem for today, just to explain that what is Euler force and what is Coriolis force and what is centrifugal force, by seeing in a what? Rotating frame. Okay guys, so now in the next lecture guys, I'm going to take few more examples on this these concepts. Okay, and then I think that would be end of the circular motion. Okay, okay guys, so that's it for today. Thank you.